All right, so let's go over this lovely exam right here. The first problem states that we have a minus a plus a. So in other words, we have minus 7 plus 7. It's the same kind of argument that this number is 0. And we could use our math lingo and call that the additive identity, but it's because we're going minus a plus a, and we know that number is 0. It could be c minus c would equal 0, or it could be something like minus d plus d is equal to 0. That's the first one. For the second one, there are two ways of really doing this problem. The first way is where you imagine this thing having a parenthesis out front. And we know we can do that because addition is associative. So we could have an a plus b and imagine that being a number. And we see that we have an a plus b minus an a plus b. So we have this number here and this number here, and we know those are the same numbers, and for that same reason before, we know that that number is 0. So we could use that argument. The other way of doing this problem is to use the distributive property. So we see the a plus b term right here, this first term right here, we see the a plus b, and then we have, recall there's this -1 hanging out here. It's there, but it's really not. So it's -1 times a and -1 times b. So we have a minus a and a minus b. And what happens here is we see the a's cancel out and then the b's cancel out. So what we're left with is nothing. So this number is really equal to 0. Either way works. Now, let's look at this one. 3. For the number 3, we know that we could have, for example, 5 divided by 5. That number is 1. So here it's the same thing as 1. We're taking a, we're multiplying it by the reciprocal of a. For this one, it's the distributor property. So we have ab plus ac. The a is migrating to both of these terms. And we can extend that to larger terms, like this one right here, and we imagine the a going to all of those terms, so they're a, b, a, c, a, d. So that's what happens there. For this one, it's the same process except there's harder looking expressions thrown in there. So we have ax squared. There's that term right there. And we have minus ac plus ay plus ae. This one, recall there's a -1 hanging out front, so it's -1 times -1, which is 1. So you should kind of be able to eyeball that and imagine this sign changing, so it's just left with 1 here, though. And for that same reason, it's a. It's a here. -1 times -1 is 1, and you're left with 1a, so it's a. Let's just look at the whole quantity. So the entire quantity, -3 squared. That number, if we have -3 times a -3, that number really is 9. So that -3 squared, that number right there, the whole, here, let's just get rid of this. The -3 squared number really is just 9. So let's get rid of that. Let's put that there. So we have minus 9 times a plus b. And from earlier, we do the same thing in distributor property. Minus 9 times a is minus 9a. Minus 9 times b is minus 9b. So that's that one. Here, since we're multiplying all our x's together, and we see that there are 1, 2, 3, 4 of them, we have 7x to the 4th power. And we have 2 y's, so it's 7x to the 4th minus y squared. What you shouldn't do, let's make this in red, this would be bad, is have a 7 and have x to the 4th and then a minus y squared. These are totally different things. This one is having our 7 and it's multiplying it by all these numbers, and this one is distributing the whole thing in. We are not doing that here. Okay, so this would be wrong. Let's just get rid of that completely. That's bad. All right. right, let's go to the next one. We see there 7x to the fourth minus 7y to the fourth, and then 7 times a minus 7 is minus 49z. And I'm just double checking. Yes, that one's good. Now let's look at number 12. Number 12, we see that there are 3, we're adding here, so there are 3 of these terms, so we have 3x to the 98th power. The reason why the 3 is even out here is really, you're taking, we recall from the distributive property that we could go, it's technically the right distributive. We imagine the x to the 98th kind of floating into all these terms. These two things are equal, so therefore we have 3x to the 98th. The way of thinking about it, you want to see 1, 2, 3 of these, so there's 3x to the 98th power. This one, for the same reason, is minus 2x to the 17th. Recall there's these 1's out front. They're really 1's. So you have minus 1, so that's negative 2. Here, this one is ax squared minus ay cubed minus az. There's just more distributive property right here. This one, well, we see that there are, here, let's get rid of that. We see that we can combine these terms together, the y squared. So let's do that. We have 6y squared. Then we see that we can combine all the z's. Recall there's a negative, there's really a 1 out front right here. So it's minus 4z. Well, actually, there are 1, 2, 3 z's. So it's minus 3z. And then you have plus x. This one is 2y cubed plus, and since we're multiplying all these together, it is x cubed. We see here, this one's canceling. They're not right next to each other, but that doesn't matter. We know we can easily move that term over here. So this one is, you're just left with y squared. Reciprocal of a is just 1 over a. The reason for it is that we have a times 1 over a is 1. So a times 1 over a is 1. That's why it's the reciprocal. The reciprocal of a over b is b over a. We know the b over a, the b's kind of cancel out with each other and the a's cancel out with each other, so it's just left with 1 when we multiply those terms together. So it's b over a. The product of a over b and the reciprocal of a over b is what? Again, I'm going to underline this. The reciprocal of a over b. So the reciprocal of a over b is b over a from earlier. So let's just write that. Sorry about that. B. Sorry about this. I know that this takes a little while. All right, so the product of a over b times the reciprocal of a over b is what? Make this a little bit bigger. So we're multiplying these terms together. We see that these terms cancel out. And we're just left with 1. So the answer is 1. The sum, recall this one, product means multiply. Sum means add. We have x squared plus 3x squared is equal to 4x squared. For this one, let's just line up our equal sign, so nice and orderly. Recall minus 2x, we're taking that whole quantity and we're cubing it. So we have minus 2x times a minus 2x times a minus 2x plus y to the 17th power, same thing, which is also equal to we see that there are, so we go minus 2 times minus 2 is 4, and then 4 times a minus 2 is a negative 8, so negative 8x cubed for that term. And then you do plus y to the 17th power. The trick to remembering why there is a negative up front is you see there are an odd number of negatives. An odd number of negatives means that you have a negative out front. If it's an even number of negatives, then it's a positive out front. For this one, it states, what is x in terms of a and b? Okay, so, oh, and there's a hint. Wonder why we do that. Just, you know what, let's just rewrite it just for good measure. Well, we have this equation here. Let's make that a little bigger. And then the reciprocal, so we're multiplying both sides of this equation by the reciprocal of a over b, which is b over a. So let's steal this one from up here. Let's move it down. And we have to do it on both sides. So there as well as there. We're super close. Okay. This cancels out with this. That's the number 1. This cancels out with this. A over a is 1. So we're left with this whole term is 1 because these all canceled out. So we have 1x is equal to 7b over a. But really 1x is the same thing as x. So it's x. So this equation becomes x is equal to 7b over a. And that is x in terms of a and b. We see x equals, and then we see numbers of b and a on this side. So that one's done. Let's go on to the next one. Let y equal to this. Then minus y equals blank in terms of x. Well, this one is just a substitution problem. So we can take our y and substitute it into here to get what x would be. So let's take our y term and let's plug it into there. And that would spit out it in terms of x right here. So let's do that. And let's do this in red because this would be something. Actually, let's do it the right way first. So you have minus y, so we have minus x to the 4th plus 5. We have our left parenthesis and our right parenthesis equals minus x to the 4th and then a minus 5. So this would be our answer right here. What we shouldn't do, this would be bad. Let's get the color red out. We shouldn't have minus y and then just leave our x to the 4th plus 5. That is the temptation of not bringing the parentheses in properly. So we put our parentheses around the y and then we substitute. And that yields the proper number every time. If we forget to do that, the temptation is to do something like this. And these are not equal. These mean totally different things. So do not do that. Make sure to close the parenthesis off and then substitute in properly here. And then use the distributive property to finish. And let's just do it one more time. Same process here. So we have minus 3 times y equals minus 3 times x squared plus 6, which is equal to minus 3x squared minus 18, because the minus 3 is moving to both terms. And then that's it.